Continuing with section 5.5. So in the last video, we were looking at the definition of tangent inverse x. And remember, we restricted the domain of the tangent function between negative pi over 2 and pi over 2, not including the endpoints. Because at the negative pi over 2 and pi over 2, we have vertical asymptotes. So the value of the tangent does not exist. So when we did that, the range was negative infinity to infinity. So to construct the inverse tangent function, we say that y is equal to tangent inverse x if and only if tangent of y is equal to x. Exactly the same way as we define the sine inverse function and the cosine inverse function. So now this is the graph of y is equal to tangent inverse x, and this graph you should keep in mind because it will come in handy in later problems, and especially in calculus 1 you will need it. Okay. So notice here that the domain of this function is negative infinity to infinity. So for tangent inverse x, the domain is negative infinity to infinity, and the range is minus pi over 2, pi over 2, not including the endpoints. So let's look at the example. First one is tangent inverse of 0. So again, remember, we are trying to find a number or a value t such that tangent of t or tangent of x, whatever you want to choose, is equal to 0. So when will the tangent be 0? Remember, the tangent of t will be sine of t over cosine of t. Since there is a fraction, we want the 0 will happen when the numerator is 0. So numerator 0 means sine of t is 0. And when is the sine t 0? Well, it is 0 at 0 and it is 0 at pi. But in the tangent t, we have to find t which is within the limits negative pi over 2 to pi over 2. So which means t will be equal to 0. So the answer to this is 0. Next one, arc tangent, it is other notation, square root of 3 over 3. So in other words, again, we are trying to find a number t such that tangent of t equals square root of 3 over 3. Now remember, this can be simplified and written as 1 over square root of 3. And we want t to be in the range, in the interval negative pi over 2 to pi over 2, and we want its not including the negative pi over 2 and pi over 2. And so this will happen at pi t equal pi over 6. No, it will happen at pi over 3. So how can we check? Remember, sine of pi over 6 will be pi 1/2, and cosine of pi over 6 is square root of 3 over 2. So this will give you 1 over square root of 3. So that's why t is equal to pi over 6. And so our answer here is pi over 6. last one, tangent inverse 1 is what? So we are finding t such that tangent of t is equal to 1. And remember, we have to stay in these two quadrants. So tangent of t is equal to 1 means t is equal to pi over 4. So again, once again, the warning that sine inverse x is not equal to 1 over sine x. The reason we are giving this warning over and over again, or repeating this warning again and again, is because remember the new notation was introduced for sine and cosine, and it's the power of sine, cosine, and these other trig functions, that if you have sine to the n of x, it is the same thing as sine of x raised to n. And this same thing with the cosine and the tangent function. But here, note that the condition was that n is greater than 0. Then we write it like that. But here, if you think of it, n is negative 1. The power is negative 1 if you think. So you cannot write it this way. Remember, this is not power. This is just a notation of inverse function. So just to come out of this confusion, that's why that other notation has been introduced. So in inverse x, instead of this, we can write arc cosine, arc sine, arc sin. We read it arc sine x. Okay, and in the same way, the cosine inverse x will be arc cos x, arc cosine x, and tangent inverse x is the same thing as arc tan x. Okay, so let's look at this next example. This is saying find the exact value of each expression. I have done some and I have left some for you guys to do. Okay, so first one, cosine inverse of negative 1/2. Sorry, cosine inverse of, hold on, it is arc sine of negative 1. Arc sine of negative 1. So again, we are trying to find number t such that sine of t is equal to 1, negative 1. Sine of t is equal to negative 1. And we have to stay within negative pi over 2 to pi over 2. So in other words, in these two quadrants. So when will this happen? Sine of t is negative 1 when the terminal point is over here, which is what is the real number associated with that point. Well, you remember, if you go this way in the counterclockwise, so this is 3 pi over 2, but you are not supposed to say that t is equal to 3 pi over 2. That is wrong. And the reason is because 3 pi over 2 does not belong to the interval negative pi over 2 to pi over 2. So you have to understand this, that you have to read it as negative pi over 2. So the correct answer will be t is equal to negative pi over 2. Looking at the next one, so we want sine of t equals negative square root of 3 over 2. So sine of t is negative square root of 3 over 2. So which means t is negative pi over 3. If we had sine square root of 3 over 2, if we did not have this negative sign, then our t will be pi over 3. But now because we have a negative sign, and it means the t is going to be in the fourth quadrant. So sine of t is negative square root of 3 over 2, and sine is negative in quadrant 3 and 4. But since we are talking about inverse sine, we cannot be in quadrant 4. Quadrant 3. We have to be in quadrant 1 or quadrant 4. Because remember, from here to here, that's where the value of t should be. So the t is negative pi over 3. If we are looking at the next one, it says sine inverse of 3 over 2. So again, we are trying to find t such that sine of t is equal to 3 over 2. But wait a minute, 3 over 2 is what? 3 over 2 is 1.5. 3 over 2 is bigger than 5, 1. So this value does not exist. So I did all these for you. I would like you guys to try some, and then we will see if you got the results correct. Okay, so now we have some more a little bit complex problems, because now we have learned how to find the or evaluate the inverse sine function and inverse trig functions, and also we know how to evaluate the trig functions. So there is a property of inverse functions, and this is from section 2.8, that if f and f and inverse are inverses of each other, then the composite function, so this is f inverse composed with f of x, which can be written as f inverse of f of x. It will give you back x if these two are inverses of each other. In the same way, if we have first f and we compose it with f inverse, it will give us back x. And these x's have to be in the domain. They will give you back x if and only if the x is in the domain of this inner function. So let's see how we apply it on the trig function. So if you have inverse sine of x, then you will get back x if x is in the domain of sine inverse. So what is the domain of sine inverse? Negative 1 to 1. Or x is in negative 1 to 1. So, and if we have sine inverse of sine of x is equal to, it will be equal to x if the x is in the domain of sine x. Now remember, we are talking about the restricted domain. So what was the restricted domain? Negative pi over 2 to pi over 2. And then similarly, we have this property, inverse function property for cosine and cosine inverse, and then for tangent and tangent inverse. So let's see how we look at these examples, problems. So just remember, we call the inverse functions what are their domains? Sine inverse x has the domain negative pi over 2, negative 1 to 1. So sine inverse has domain negative 1 to 1. And range is negative pi over 2 to pi over 2. Cosine inverse x has the domain negative 1 to 1, and it has the range 0 to pi. And then tangent inverse x has domain negative infinity to infinity, and range is negative pi to pi over 2 to pi over 2, not including the endpoints. So now if we have to solve examples like this, example 5, first problem. So we have sine of sine inverse of 3 over square root of 10. Now this is a number that we have not seen on the unit circle. So how will we solve this? Well, we can use the, try to see if we can apply the inverse function property. So remember that 3 over square root of 10 is a number which is less than 1. And so it is a number between 0 and 1, which means it belongs to the interval negative 1 to 1. So by the inverse function property, our answer will be just 3 over square root of 10. Okay, so you guys can try the next two. Looking at number 4, it says sine of sine inverse of 5. So what will that be? So we have to now check, does 5 live in the domain of sine inverse x? Well, sine inverse x had the domain negative 1 to 1, and 5 is not in there. So this is not, does not exist. Why it does not exist? Because the first equation that or the first equation that we would be solving is that, is there a number t such that sine of t is 5? That does not exist. So which means we cannot evaluate this quantity, so it does not exist. Similarly, now you should be able to look at this and this question. And now I'm going to number 7 here, which is saying that tangent inverse of tangent of negative pi over 3. So in the previous examples, the inverse function was inside and the plane function was outside. And now we have the plane function inside and the inverse is outside. So this is saying tangent inverse of tangent of negative pi over 3. Now remember, this will not be always be negative pi over 3. You will not always get this as your answer, the argument or the value as your answer. You will get it only if that value exists in the domain of the inner function. So the domain of tangent was, remember, negative pi over 2 to pi over 2, which lives in, you can think of it like as a interval, or you can think of it like a interval or on the unit circle. So what I'm trying to say is that we can have the, think of it like minus pi over 2 to pi over 2. So which is, and these are not included. So does negative pi over 3 lie in between somewhere here? Yes, it does. Okay. Or you can think of it like does negative pi over 3 lie in here? So we would say yes. Why? Because pi over 3 is here, so negative pi over 3 will be somewhere here. So it lies within that region. Therefore, we say we can get negative pi over 4. So in order to show work,